Hey guys, today we're going to be learning about the surface area of prisms and pyramids. We already learned about the volume or the inside space. The surface area is like the outside. So for our definition, surface area is the sum, that means we're going to be adding, right, of the areas of all faces, or surfaces. It's just a word for surfaces, on a 3D shape. So if I had a three-dimensional object like this, the area of every surface added up, so all the surfaces together is the surface area of that shape. Now we're going to look at surface area using nets, and a net is just a pattern obtained when a 3D figure is laid out flat showing each face of the figure. So going back to that one I was just holding up, it's a three-dimensional box or prism, but if you fold it out, you make a net showing each face. It's like it's just laid out flat. That's a net. Okay, so we're going to start with some nets here, finding the surface area. And this one tells us that this side is 20 feet. And all of the sides are equal. So this is 20 feet, and this is 20 feet, and this is 20 feet. Every side is 20 feet. So what we can do is take the area of one of these, say this one here, and we say, okay, the area of that square is length times width, right? And we know that it's 20 times 20. So the area of one of those squares is 400 feet squared. Remember, when we find area, we're multiplying 20 feet by 20 feet, so we get feet squared. And then all we need to do here, since all of the boxes are the same, we just need to count up how many. There's 1, 2, 3, 4, 5, 6 boxes. So if we just take 400 times 6, we would get 2,400 feet squared. So the surface area of this cube is 2,400 feet squared. Okay, let's look at another example. It's a little more complex now. All right, now we've got this guy, and these are not all the same, but we can find ones that match to minimize our work so that we don't have to find the area of every single one. So I see that this is the same as this, so this is 3 as well, and this is the same as this. So these two boxes, 1, 1, are the same dimension. So I'm going to go ahead and calculate the area of this box as 3 times 5. So it's 3 centimeters times 5 centimeters, which is 15 centimeters squared. And I'm not going to worry about how many there are yet. I'm just trying to get an area for every surface. Now this one, notice, is 3 by 12, and this is also 3, and this is also 12. So these two match. Okay, so the area of box 2, that size, is going to be 3 centimeters times 12 centimeters, which is 36 centimeters squared. Okay, and then finally I've got these guys, which are also 5 by 12. So these match. The area of the third type of box is 5 centimeters by 12 centimeters. When I multiply those together, I get 60 centimeters squared. So I've done half the work now. I know the area of each surface, but I need to make sure that I count them all. So I know that there are 2 of the 1s. I see that there are 2 2s. And there are 2 3s. So 1, 2, 3, 4, 5, 6, 2, 4, 6. I know I've gotten every surface now. So now I just need to multiply 2 times whatever the area is. So the area of 1 was 15, so 2 times 15. The area of 2 was 36, so 2 times 36. And the area of 3 was 60, so 2 times 60. I'm going to get my totals. 2 times 15 is 30. 2 times 36 is 72. And 2 times 60 is 120. So now I have all my areas. I just need to add them up to get a total. So 2, 12, 1, 2. So 222 centimeters squared would be my final surface area. So again, it's just adding up all the surface areas. And if you do it this way, grouping ones that are alike, you don't have to calculate area for every single one. Okay? Now, if we're given a 3D figure, we're going to do it the same way. We just kind of have to make the net in our head. So if I notice that this box on the bottom, the very base, I'm going to call that 1. It's 35 by 35. And I see that the one on the top is also the same. They have the same dimensions. So I'm going to also label that 1. So I'm going to go here. So the top and bottom of my figure, which we're calling 1. The dimensions are 35 meters by 35 meters. When I multiply those together, I get 1,225 meters squared. Okay, so that's the top and the bottom. Let's look at the sides. So I notice that the side here is going to be 35 by what? 56. Okay, and the side here is also 35 by 56. Okay, so let's take the sides. And this is the area of type 2. It's 35 meters by 56 meters. When I multiply those together, I get 1,960 meters squared. All right, so now I'm left with the front and the back of my box. I'm going to label that front and back. And that's going to be the third type. Okay, and if I look, 35 by 56, it's the same as the sides. Now, it won't always be, but this one happened to be the same. So type 3, front and back surface, okay, the front and the back, are also 35 by 56. Now, if we had noticed that earlier, we could have combined those, but it's always good to check top and bottom, sides, front and back. That makes sure you're not missing any of the faces. So this one's going to be the same thing. Okay, so now we just need to add up. So there's a top and a bottom. That means there's 2 of the 1s. There's 2 sides. So that means there's 2 of the 2s. And there's a front and a back. So there's 2 of the 3s. Okay, and again, you could have combined this to make 4, but it's probably a good idea to think through front and back, side, top and bottom to make sure you get everything. So again, just like before, I'm going to multiply. There's 2 of each of these. So I'm multiplying them by the area. The area of 1 was 1225. The area of 2 was 1960. The area of 3 was also 1960. So let's get those totals. So 2 times 1225 is 2450. 2 times 1960 is 3920. This one will be the same, 3920. And then I add them all up to get my final total. And so when I add them up, I'm going to get 10,290 meters squared for my total surface area for that one. Okay, so that's prisms. Let's look at pyramids. They work the same way. It's just that some of the sides are going to be triangles now, so we just have to be careful when we're calculating the area. So let's start with this middle piece. This would be the base of our pyramid when we put it together. So we'll call this area of the base. And I'm going to draw a square around it just so I know I'm dealing with a square to remind me I'm doing length times width. And it's a square. They don't tell us that these are different sides, so it must be 25 by 25. 25 meters times 25 meters is 625 meters squared. And then I have 4 triangles, and they don't have any different markings, so they must be the same. So let's do the area of a triangle. Remember, the basic formula for that is base times height divided by 2. So don't mistakenly calculate the area of a square instead of a triangle. Remember, these are triangles. So the base of my triangle is the same as this, so it's 25. The height of my triangle is 9, and I need to divide that by 2. So when I do that, I get 112.5 meters squared. So now I just need to figure out how many of each thing. So there's one base. It's square shaped. And there are 1, 2, 3, 4 triangles. So base is just 1 times 625, but triangles is 4 times 112.5. So we're going to have 625 plus, and when we multiply 112.5 times 4, we get 450. So my total surface area is going to be 1,075 meters squared. Just again, added up all the areas for everything. Okay? Now remember, there are different types of pyramids. This one had a square base. This one has a triangular base. So I'm going to do this one area of the base, but I am going to put it inside a triangle to remind myself that I need to use the base times height divided by 2 formula. So let's look at just this middle triangle. The base of this one is 6, and the height of this one is 5. So 6 meters times 5 meters divided by 2 would be, 6 times 5 is 30. 30 divided by 2 would be 15 meters squared. And then all my side triangles are the same as each other, but they're not the same as the middle. So you always want to check and don't just assume that they're all the same. Oops, that should be a triangle, excuse me. So here, again, it's a triangle, so base times height divided by 2. The base of my side triangles are 6, but the height are 7. So 6 times 7 divided by 2 would be 21 meters squared. So again, I just need to count up how many. I have one base in the middle, but I have 1, 2, 3 sides. Oops, and I should have moved this down. Sorry. All right, so I'm going to go ahead and multiply 1 times the area of the base and 3 times the area of the side. So the area of the base was 15. The area of the sides was 21. 1 times 15 is just 15. 3 times 21 is 63. And then I add them together. Okay, so I've got 8 and 7, 78 meters squared for my total surface area there. All right, Now, finally, our last one is going to be a three-dimensional version of a pyramid. So instead of it being splayed out in a net, it's just three-dimensional, but we just need to visualize it. I see clearly there's a base, so let's start with that. So the area of my base, and I notice that my base is a square or rectangle, so I'm going to put it that way. And it says 7, and there's no other markings, so it must be 7 by 7 square. So 7 centimeters times 7 centimeters, which means it's going to be 49 centimeters squared. So that's the area of the base. And then all these triangular sides are the same. So let's find the area of one of those. Remember, it's a triangle, so base times height divided by 2. So the base of my triangle is the same as the side of one of these squares, so it's 7. The height of my triangle is 5 divided by 2, and that would give me 17.5 centimeters squared. So now I just need to figure out how many of each. There's only one base. How many sides are there? 1, 2, 3, 4. If you're having trouble visualizing, look at the base and count 1 for each side. 1 comes up this way, 2, 3, 4. So there are 4 triangular sides. So I'm just going to do my multiplying. 1 times area of the base, 49. 4 times area of the side, 17.5. When I do that, I get 49 up here. And then 4 times 17.5 is 70. Add them up. And I'm going to have 119 centimeters squared. All right, so your practice slides have a mix of nets and 3D pictures. There's a challenge at the end if you're interested. And let me know if you have any trouble.